they get none. Like I said, this is not very descriptive because we don't know what went wrong. But you can see how this can easily be solved by using something like an either or a try instead of like simple option and adding some additional information. And we have also the tree example from before, just so you'll believe me that it also works. So I have some tree here, and I can run it and get the deserialized tree. All right, I think this is about it. Unless you have any questions you want to ask. All right. So we can take a few minutes break and
Let's make it 5 minutes break.
5 minutes break. Great.
Make an alternative stream right now, so like you guys can see because some of my slides are not seen.
Mm.
They are coming from the camera, but when they're captured from the screen, then
So now they can see it.
yeah.
All right.
Получается, сейчас задержка будет 2 секунды одна возникнет. То есть они прямо в реал-тайме могут сделать через 5 минут.
So no need to send you the rest of the slide, right?
Не, по идее.
Это та же ссылка?
Не, новая ссылка, просто там в лучшем качестве и оно останется в этой ссылке. Когда без задержки, оно не может записывать лучше. Ну, короче, 2 секунды сразу.
Короче,
Один сохраняется, а второй в реал-тайм.
Да.
Окей.
Потому что тот, который в реал-тайме,
А
он не
можно
может
тогда
записывать.
ссылку мне на тот, который в реал-тайме?
Да. Вот делай это сейчас.
Попробую его включить потом. Amitai, can you tell something? I want to check the audio.
Hey, 1, 2, 3. How does it sound?
Не так быстро все-таки или нет? Все нормально? Нормально? У нас видно, что это нормально? У меня нормально, потому что я это на YouTube, ну, то есть мне это понятно. Ага. А он где?
Nikolai, do you know this joke? Like, once you understand monads, you lose
You
the
can
ability to explain them to other people.
Yeah, this is why I didn't try. I just said it involves a
Yeah.
I think that if it had like more approachable name for programmers, they wouldn't be considered so like so intimidating. Like if a functor would just be an interface called mappable,
Yeah.
but because it comes from like a category theory, it has all these really
Yeah.
specific laws. So
Yeah. And monad, it's a profunctor in the full name of the
yeah, like
monad is
like a functor in the category of endofunctor,
Yeah.
something like that. I'm not too good with these definitions myself.
it's
So
like easy explanation.
yeah, what's so hard to understand? Yeah. Shall we continue? Great. Okay, I hope everyone's still awake. So I understand that event sourcing is like a topic that many of you like deal with every day, with its pros and cons. So I'm gonna describe here the event sourcing library we built for the Wix Invoices project about 2 years ago, me and Lidan, you may know him. So here goes. So first of all, a little background. We started Wix Invoices just shortly after me and Lidan started work in Wix. And which is quite unusual to give like two new developers like a greenfield project to start off from scratch, which is in some ways it's nice that you can do whatever you want, and in some ways then all the design problems are like are on your shoulders and you can't blame anyone else. So this project had like a rich domain model. An invoice is like a complex object with many different like sub-objects and all sorts of like domain rules regarding everything, the tax calculations, and how the line items are added or removed and stuff like that. So this was one part of it why we chose to use event sourcing. Another is because this is like a monetary product. It involves money. We have like a lot of money going through the system. So auditing is an important part of it. So after some research we did, we considered both like the library ecom we're using and some other libraries we found online. We decided to go for an event sourced architecture, but we wanted like a really like simple solution. We didn't want the full-blown framework that will like tie us to all sorts of implementation decisions. One other thing is like I talked about with a few of you guys previous this week. So we had a few limitations that were important to us. For example, like really good domain validations prior to saving any events, and we wanted like a flexible view model. So we decided to go for like a solution we developed as we go. So like I said, most of you aren't familiar with this concept, so I'm just gonna like really briefly gonna skim over what event sourcing and SecureOS are. Just if anyone is not in line here, and then I'm gonna talk about Eventim. So regular issues with CRUD is basically we have this place where we put our data, and we have new data, we just override the previous data, which is not something, this is an assumption we take as developers, but product may not like it that we're deleting data and we're losing valuable information about the history of our product. Also, evolving your domain organically is hard because as your domain objects become more complex, it's hard to adjust your tables to accommodate these changes because you're very you get into coupled to your like tables and their structure, and you want to evolve your domain how it evolves organically. So, and this is another problem. Also, if you try to issue like complex queries against the SQL database, unless you have like a solution based on like denormalized data, it'll be hard to scale, and you'll get into all these weird join queries with like 50 lines of SQL that no one can really understand. And if you want auditing in such a system, this is always like an afterthought. You don't get it from the start. If you understand suddenly that you wanted to understand how you got to a certain point, you can add like BI events and stuff, but you don't have any historical data. You can just start collecting new data about it when you add it. So these are some issues we have with CRUD. So the event sourcing approach basically says that instead of saving our state somewhere, just putting our state in a mutable place, we use like an append-only log to which we persist just the changes that brought us to this event. And these events are like really closely related to our domain, and they describe domain actions and not like technical issues. So when we want to read our current state, it's simply like a fold left on the event stream with some empty state, and then for each event we just apply to the new state, and this is how we know what our current state is. So in the invoice example, we have the invoice created, we get a new fresh invoice, and then, for example, line item added, another line item added, line item removed, invoice sent to customer, and payment received. And from this sequence, we can easily tell the state of the domain model. CQRS, just a fancy way of saying that reads and writes are treated differently, because in most production systems, you will get these different scale requirements. I read somewhere that you get about 90% of your requests are reads versus like 10% writes, so we need to treat these separately and not treat them the same with the same model. Also, we usually can get different consistency guarantees for reads and writes, because when we write something, we want to ensure that the state is consistent. We don't get to any domain validations, but for reads, it's usually it's a product decision, but usually it's okay to have like eventual consistency. It doesn't matter if you'll see the invoice just a second after you added it or immediately, because in terms of product, usually it's good enough. But again, this is a product decision and not a technical decision. But products need to be aware of it. So in CQRS, commands are used to change state, and actually they don't supposed to return any like read state. And queries are used to query current state, but they're not supposed to affect the world, because asking a question should not like change the answer. So they're not actually related, CQRS and event sorting, but they play very nicely together. If you decide that your commands, all they do is persist new events, and then if you listen on the event stream, you can create denormalized views or read models that are optimized for your queries, and your queries can be really simple and lean, no need to do like the complex SQL with many joins. Also, you can quite easily, and at least the premise is that quite easily you can introduce new read models, because you have the entire history, so you can just play all events from the beginning of time and get your new views ready. All right, so about event team, the main design goals, and that I must admit were not fully achieved. Like I said, we wanted a simple and small library. Didn't want like a full-blown framework that will tie our implementation and leave us with less freedom to do what we want. We wanted it to be non-intrusive, to define our domain model and domain rules in terms of our domain and not in terms of some framework. We had a strong case for validations. Like I said, this is like a product which really relies on on state being correct, and we can't have um, mutations which are not which violate like business rules. And we wanted the ability to add custom views, because we knew that we're gonna have a lot of like different requirements regarding all sorts of from tax reports and advanced searching options and a lot of stuff that we wanted like to have a really good solution for. So in Eventim, the right path goes as follows. You have the user interface from which you issue your commands, which are just JSON objects. This command will get to a command DTO decoder, and this will validate the command structure. This is like primitive validation. It doesn't involve yet business rules. It just like make sure, for example, the customer name is not empty and the price is greater than 0 and stuff like that about the actual command structure. And if a command is parsed successfully, we can create a domain command object from it. And this domain command will reach the command dispatcher. The command dispatcher holds inside it several like command handlers. Each command handler is simply a partial function from a domain command to unit. So each handler knows to deal with a set of predefined commands. And the command dispatcher will try to find the correct handler for a command and will use it to apply the command. So taking like a deeper dive into the base. Now, this part is not related yet to event sourcing, because your command handler can do anything. We have also in Wix invoices, we have a command handler which just updates some really simple domain object that we decided not to use event sourcing for. It just uses like basic CRUD to update. So this is still like the CQRS part. But we have this type of command handler, which is event sourced command handler, which works as follows. Now, the command comes in. It will first try to load current status of the aggregate. The aggregate is the domain model. The aggregate root is the object which defines the boundary of your operation. So the aggregate repository will usually go to the event store, fetch these events that are related to that aggregate, and rebuild current state from the event. And once we have the current aggregate, if the command is an event sourcing command, it will know how to produce the relevant events for this command. So we have the events, we have the current aggregate. We can apply the new events to the current aggregate to create a new aggregate. At this point, we have everything we need to make like business decisions based upon the current aggregate and the new aggregate, and decide whether this operation is valid or not. So this is where we can add additional validation rules. And if everything succeeds, we can persist the new events to the event store. We use optimistic lock-in to ensure that there are no like concurrent writes, because if another command is executed concurrently, we can ensure that that this command is valid for some version of the aggregate. And if this version advanced since we started to run the command, we can reject the operation, then the event won't be saved. And if the events were persisted successfully, we will publish them to an event bus. Now, this is basically the end of the write path, because once we have the persisted events, so to us this means the operation succeeded, and we can take a look at what the read path looks like. So we have events coming in through the event bus, and the event bus can be, you can subscribe to it, to any event handler you want, which again is just a function from a domain event this time to unit, because it just does some side effect. So for example, we can have an event handler which denormalizes some view for our read model. So this will usually persist some data to storage, which will allow us to later issue the queries against this database in a way which fits us the most. In invoices, for example, we have mail handlers for sending emails, because when a customer wants to send an email, we will publish an event that the user requested to send the invoice, and then we can listen on that event, and if we see it, we can do the actual sending, and if sending succeeded, we can persist another event that sending succeeded or failed. Also, we have event handlers for reporting or BI. Adding BI to the system was, to invoices, I mean, it was extremely easy. All you did was just add a new event handler, which for each event published the corresponding BI event. So it didn't like, it was not mixed in our domain logic. It was really separate and decoupled, and it was really easy to implement. And after we have these views ready, we can use, like I said, simple queries from the user interface without much logic in them, without the complex queries. In invoices, we have several views which are saved to MySQL. One Elasticsearch index we use for full text search. And this is basically what the library provides you. I will now, in a second, first of all, a bit about the challenges faced with dealing with an event source system. I assume that most of you experience some of these every day, because this is unfamiliar developmental model. Most of the developers are not used to work this way, and need to change the mindset you are in. Start to think about domain changes in terms of events, and not having in-place state you mutate all the time. Beside that, there's some operational complexity, because once you start working with events, then you don't have the tooling you're used to, because you can't just check the status of your domain by issuing queries to the DB replica. You need to invest in tooling that help you analyze current state and help you analyze and debug the system. But the biggest challenge, I think, was to introduce new views and to rebuild new views, and I will later share with you one solution we implemented in invoices that helps us to deal with this problem. But first, I'm gonna do a real quick example on how to use Wix Eventim and how it feels like to work with the library. All right, so I'm gonna do the basic canonical example of a bank account, because this really is used in the textbooks to describe event sourcing systems. Okay, so the first thing I'm gonna do, I'm not brave enough to do real live coding, so I have these commits prepared. So first step, I'm gonna create our domain model, which is a simple Scala case class. It has some properties about the bank account. It has an ID. It has a bank account owner, which is just the name of the owner, and current balance. Now, this domain model, like you see, is purely functional. You can issue these operations on it, deposit and withdraw, and this is really easily tested. Now, once we have this domain model, we can add the events that change the state of this model. So, for example, in this case, we'll have a seal trait. This will describe every bank account event. And we have an account created event, owner change to a new owner, deposit performed or withdrawal performed with the amount. And afterwards, we can add the command. Okay, so as you can see, similarly to the events, we have bank account command. This extends the event producing command, which is like the new way we like to deal with commands. Once we didn't really have the events produced by the commands themselves, we had another class that like did the transformation from a command to the corresponding event. But we now think that this is like the preferred way because this is like more decoupled and you can check the commands like on their own. So for example, create account command takes an owner and initial balance, and all it does is it produces these events: account created, order changed, and deposit performed for the initial balance. The commands also allow us to do some domain validation. So if we want to withdraw some money from the account, we first we always get the current state of the aggregate when we perform the command. So we first check if the withdrawal is approved, which just checks if the balance is greater than the amount we want to withdraw. If not, we can throw that the balance is too low. Otherwise, we publish this event that the withdrawal was performed. Again, all these are still purely functional. All the parts are connected using the library, but this is really easy to test. I mean, it's just a function that returns you a sequence of events. And similarly, we can deposit. You can always deposit. There are no business rules here. And after we do that, we can add event handling to the aggregate. So at this point, we're telling that the bank account is an aggregate root, event sourced aggregate root, and then we can define what are the command types and the event types that this aggregate knows. This is something internal to the library. And you can define the handle method, which takes an event and needs to transform the aggregate according to the event. Now, at this point, the event was already persisted, so you must not throw exceptions here, because when you try to rebuild the state from the saved events, you don't want an exception to be thrown. So everything that is done here, you must deal with. I mean, it's not, if you want to reject some command, you need to do it in the previous stage where you define which events are produced by a command. But at this point, you have to deal with it, and if you don't know the event, you can just return the current state of the aggregate. So this is, okay, so one more thing is you need to define like the empty state for an account, because when you want to rebuild state, you need to start at some point. So here you have like an empty bank account with an empty owner and initial balance of 0. And this is basically your job as like a project maintainer to define the business rules and how your aggregates play and what events are produced. The rest, the glue part, is in the library. So if we look at the actual example of putting everything together, let's check out master. Can you see okay the code? All right. Okay, so let's go over what's going on here. Okay, so first we create our event store. Now this is, in this example, uses MySQL. we also have implementations for Cassandra, and we have a pull request for like an in-memory version, but I don't think it was merged. It was like some Guild Week task, and I don't know why it's not merged yet. So gonna have to check that. After we have the event store, we can define the event service, which what it does is allow us to publish new events. It will persist the events to the event store and publish them on the event bus. Now, again, this is implementation of an in-process bus that just lives in your process. If you want, for example, strong consistency on something and you don't want to use like async event handling with Kafka or whatever, you can run the events as your commands are issued. So this is quite simple. Then you can create the aggregate repository, which will allow you to load the state of your aggregate, and create the command dispatcher, which is a command dispatcher with handler. Like I said, it can contain many handlers, and it will choose the first one that can handle a specific command. So the event source command handler takes the repository in the event service and will handle the bank account command. Now, just an example, we create random IDs for the account and the instance ID. This is another thing we had in this library, which in retrospect, I'm not sure it was a good idea. We have like everywhere we have the instance ID, which might not be like generic for all use cases because not all projects like have the notion of tenancy and stuff like that. So because we start off by like doing it as we went and not trying to make anything like too generic. We wanted it to fit our needs, and for now we saw a few other use cases in which it worked well, so I'm glad about that. Okay, so now we can handle a few commands. For example, creating a new bank account, depositing some money, withdrawing some money. And after everything, we can check the repository and load current state. So if I just try to run it, you can see a lot of crap coming out from the MySQL, embedded MySQL, but in the end, oh no. Oh, come on. Yeah, just in time. Okay, we'll let it run for a bit. We'll just continue afterwards. Yeah, sure. Right.
So the question is, how do you handle the race condition? Let's say the same aggregate is being updated at the same time.
Mm-hmm. Right, so when we issue the domain command, now it is not shown here, but let's see. First of all, this goes in two places. First, the domain command itself, we can see it has like the instance and aggregate IDs, the command data, and we have expected version of the aggregate. So when a command is issued from the client side, before they issue a command, we give them, okay, this aggregate is currently at version 10, for example. And when they run new commands on it, they have, okay, I expect this aggregate to be at version 10. So when I handle the command, and we can see it here, okay, first I load from the repository current state of the aggregate. And where is it? Okay, the repository actually deals with that. If the expected version does not match the current version of the loaded aggregate, it will throw like illegal version. This is the first part when we can quickly realized that this command was not issued like on an up-to-date state. The second part is when we persist events. So each event has the version. And when we save them, the version is part of the primary key in the table. So if a command, an aggregate already has like a version 10 of the event and it tries to save another version 10, it will fail. This is the optimistic locking part. So these are the two places we can identify like concurrent modifications. Okay, so I'm gonna talk about like the part we built to handle view rebuilding, and then we can return to the example to see if MySQL finished downloading. Okay, so can you see it all right? All right. So the basic flow of a view denormalizer, which needs to create your read models, is to listen on the event stream. And basically it has some method to handle a domain event, which will usually persist the data to some database, which will be simple for the read side to later query, like I mentioned before. So, like I said, the view can be anything. We have MySQL tables and Elasticsearch Index, but you can do all sorts of crazy stuff like graph databases or in-memory views or whatever you want. So we chose to read this event stream of Kafka and not directly from the in-memory processor for several reasons. First, it allows you to easily use consumer groups for each view. So you can have a consumer view which handles with this view, which is unrelated from another consumer group, and thus you can quite easily gain parallelism by applying these changes concurrently. Also, Kafka gives you partitioning and ensures orders per partition. So we use partitioning by instance ID, and then we can ensure that every event for a single site is handled in order, and we don't have like strange conditions. But we don't care about order between different sites because they are unrelated. So with these features, we can gain nice parallelism and introduce new consumer groups with new views. So this approach still has some problems. The first problem is when we want to introduce new views, because I can't just deploy like a new view denormalizer and expect everything to work, because it will now start to accept new events, and it doesn't have like the state, the history, all the history we need. We need to apply all the history before we can handle some new event. So we can't yet write to it. So we introduced a new component, which is called handled events checker. This is a simple interface with two methods to check whether some view for some site will handle. It returns Boolean, yes or no. And I can set, okay, this site was handled. Now I know that Ecom also has a view spec class somewhere. This is like accidental. This is just a case class which describes some view, okay? So I can check whether, for example, the invoices list view was handled. And now we can use a view denormalizer and wrap it in a new component which is called Greyhound Views Processor, which will handle the incoming events according to this flow. So a new event arises from the events topic. Firstly, we check whether or not we already handled past events for this view for this site. If we did, there's no problem like adding the new event, and so we just apply it using the view denormalizer, and it will update the view. Otherwise, if this is like the first time we see an event, so we first go to the event store and fetch all past events. We handle every past event, and before we handle the new events, and afterwards we can set the handled, so next time the handling will be quick through the short path. So this solved the problem of introducing new views from the right side, but we have like the same problem from the opposite side of when we want to read views. So if I deploy a new view, but no event comes in like to trigger this whole flow, and a user comes to the site and asks to read this view, and we still don't have the state ready. So for this, we added another component, which is called view build trigger, which we use before we try to issue queries through the DAO. We want to make sure that the view was rebuilt. So this works as follows. If I ask rebuild some view synchronously, firstly, similar to the right path, we will check whether or not this view was handled. If it was, then I return rebuild not needed because there's nothing to do. You can go ahead and read from the table. Otherwise, we publish a fake trigger event to the events topic. Now, this is not an event that is persisted in the event store. It's just some fake event we send to Kafka in order to trigger the whole rebuild mechanism. And it doesn't matter that if in the same time, like someone writes to the event store, because it will go through the same path and everything will eventually reach Kafka and trigger the rebuild flow. So after we publish this trigger, you're going to poller on the was handled method for a while, sleep a little, check if it was rebuilt already. If not, we're going to sleep and wait again unless the timeout expires. And if we succeeded, we return view rebuilt, and then you can go ahead and read from the view. Otherwise, we return view rebuild timeout, and usually it will throw an exception if it takes too long to rebuild, and then the write fails, the read fails, sorry. Okay, so this solved the problem of reading new views. The third problem we have is when we want to fix or update an existing view. So if we added a view, and later we discovered that something in the logic of the denormalizer is node. Okay, I don't want to update now. Something in the logic is not correct. We see that something went wrong, and we want to add some new column. There are a lot of reasons a view denormalizer might change. So in this case, to the view spec I mentioned earlier, it describes some name of the view, which is some unique identifier for each view, but it also contains a field for when this view was last updated, which is just a datetime. So when we check whether or not a view was handled, we also verify that the last update is correct. So this is also persisted in some table. We have instance ID, view name, and update time. So if we update a view, we can simply update the denormalizer and then deploy again with the last update, like increased to current time. And then every like entry which is not up to date will be forced to rebuild again. But in order to achieve this, we also need to add a new method to the view denormalizer. This is a reset method because we sometimes, if something was malformed in the logic of the denormalizer, we want to reset state before rebuilding the view. So usually, again, it depends on the view, but usually it will, for example, delete all records from the table which belong to this site. And we get the updated flow, So if was handled returns false, either if we never deal with this view or the view was updated. So we first fetch all past events like we did before, but now before handling all past events, we want to reset our view, which will clear our state. And then we continue with the flow we had before, handle the past events, we handle the new event, and then we set handle to true, and this will update the table. And this is basically the mechanism we use in invoices to add a new view. We have, I think, like 6 different views that were built this way. And it worked out really well. But there's still some problem with this approach. Well, basically, when you want to update some view or add a new view, even though this path causes like lazy migration because it will not update everything when you start, it will on demand migrate every site. But as traffic increases, there are still a lot of sites when you update something that will be try to update together, and because most of these denormalizers usually like issue like update commands to the database, there's like a really big burst in the beginning on the database, and you can see the graphs spiking, and you get a lot of get to this view build timeout because everything starts to slow down. It eventually decreases and everything like works out, but the initial like burst is still a little bit painful. So we have a new mechanism which is not yet deployed. So I don't know if in practice it will actually work. But what it does, it uses Google Guava caches, which allow you to define in-memory cache with like eviction policies. You can decide that if the cache has more than, for example, 1,000 entries, or if an entry is stale for more than like 100 milliseconds, it will be evicted. And you can add removal listeners, which will tell you when an entry is evicted. So we have a new mechanism that uses these caches to rebuild the state initially in memory. And after the state is rebuilt and the entry is evicted, then it will be actually saved to the database. And hopefully this could save like the pain of the initial burst of queries to the database. But I haven't checked it before because it's still not merged. But this is just like another example of a solution you can go and try if you have these sorts of problems. So let's see, what about just 60? Oh, okay, finished. So let's return to our example. So after we issue these commands we saw for create and depositing and withdrawing, so we see after everything MySQL outputs, we get the final state of the aggregate. This is a snapshot of the bank account. The owner is John Doe, as you can see. He has a balance of 80 after all the deposits and withdrawals. And currently this aggregate is at version 6, which means there are 6 events saved for this aggregate. Now if I try to issue some illegal command, either if I try to violate business rule by, for example, withdrawing $100 and this account we know at this point only has $80, so we see that okay, so this failed. We get a balance too low exception, unable to withdraw amount 100, current balance is 80. So this is when we violate a business rule. Oh, didn't mean to do that. Nope. Or, like we mentioned earlier, if I try to dispatch, we know that at this point the aggregate is at version 6, but if I try to, for example, deposit $20, this should succeed, but if I assume that the current version of the aggregate is, for example, 5, the command should be rejected because this is a concurrent modification. So let's see how this goes. Yeah, version mismatch, expect aggregate, expect to be at version 5, actually at version 6. So this is this. Also, we can easily add like new handlers on the event bus. So for example, event bus, I can subscribe new domain event handler, which handles the event by, for example, matching on it. No, that it's a partial function and just case domain event. Don't care, I don't care. For example, I listen on deposit performed with the amount. I have some more fields here I don't care about. And then I can, for example, print and deposited amount into account. Deposited. If I run it like this, and we looked for there are a lot of garbage here, but we can deposited. Here we can see the log messages deposited then into account or 100, whatever. So this is the basic demo of Eventim. Yeah. So that's it. I'll take questions if you have them. Yeah. I think it is true, but okay, I'll repeat the question. Taras asked if we have, is it true that we have different Kafka clusters for each data center? To my knowledge, this is true, but when we move traffic between data centers, they first, I think, drain the topics in the Kafka before like receiving new ones on the new cluster. But this is, I think, a question for Greyhound people. Supposedly, I don't want to answer. Yeah, that's true. Also,
and that happens sometimes that we have traffic to two data centers. But Kafka, by design, as far as I'm aware, it should reside in one data center. I mean, like you do not make Kafka cluster in separate data centers. In general.
Yeah, this is the classical like master problem we have at Wix, which doesn't have like easy solutions. I mean, not all of us feel it like daily, or not all of us know that we have problems when we do. I think that the MetaSite team knows it very well because they always live on several active data centers, and they have all sorts of replication fun stuff happening all the time. So yeah. Yeah.
By definition of open sourcing, commands signal that something should be happening,
Mm-hmm.
and events signal that something have happened.
Mm-hmm.
So, by definition, event sourcing, we should
I'll repeat the question. So in basic event sourcing literature, commands represent something you wish to be done, and events represent something that have happened. And the business logic should reside in between the two. So yeah, even though the commands are called commands, I think a more appropriate way to call them is like a wish. It's not a command because a command must be fulfilled, and a wish might be granted or might be rejected. So this is exactly where the business rules apply, and you decide to use your domain logic when you receive a command to decide whether or not the command will be granted and the events will be persisted. Yes, so the command should call out to your like domain model and business rules.
So we can use some side effect in code, yes, in handlers.
In which handlers? Command handlers or event handlers?
In command.
It depends, like everything. We do use some side effects in some of our command handlers. This is sometimes inevitable if you need some guarantees on on your domain model. Usually, when possible, it's best to avoid. But sometimes, yeah, you need to do it. Anything else? Right. So thank you for listening. Sure.
How, like in the real service, how do you usually? The question is about view denormalizers.
Mm-hmm.
So you have several views right now, right?
Mhm.
And several view denormalizers. So they're deployed along with the main service.
Yeah.
Uh,
Conceptually, they could be deployed independently because all they need to do is listen on the Kafka topics. So in our case, yeah, they're deployed with the main service, but conceptually you could decouple them. Just to give you like an example of what this looks like in practice. So if you denormalize a trait, we see several like implementations. For example, this one, product list denormalizer, will denormalize the flat list of products. So you can see it has the reset method, like we mentioned, that will just delete every entry for this instance ID. And when it handles new events, for example, when a product is created, it will insert the initial row. When product name is set, we update this row with the new name, etc. Update description. This is like really simple logic, really easy to test. Or like I said, you can do anything like you want, like the search denormalizer. This will go to Elasticsearch and update the document that indexed in Elasticsearch. So you see different use cases, but everything just is very contained, and you just need to test it by issuing events and seeing that the expected data was saved, and the library takes care of the rest. Yeah, all right. So we'll take a few more minutes break. Great.
handlers, they are like invoked synchronously, right?
Well, I showed it synchronously, but actually, you can do many things. We have exit presentation mode. Okay, so this is the event handler I demonstrated. I can put it as handler. We have some additional like decorators, like new, I think, event handler decorator. Right. So this will take an internal handler and some retry policy if it fails, and this will invoke the event handler with a future. One other thing you can do is, instead of using like the in-memory event bus, use the Kafka event bus, or if you want some asynchronicity. But we wanted to do it like in a composable way. So the event handler itself is simple, just a function. If it's just a function, and if you want this capability, you can simply decorate it and gain it.
By default, the views are being built as the events come in,
Yeah.
right?
Yeah. Not per demand. Yeah.
Yeah.
Question. We thought about rebuilding view and we got some idea. I don't know if it's good or bad. For example, if you want to rebuild view, then we create new table. For example, if we add new column, we totally create new table. We copy view,
Yeah.
for example, and populate old view and new view at the same time.
Yeah.
And new view also should contain some logic to lazily rebuild everything. Then, for example, you don't need this reset method because
Yeah, that's right.
Is it a good idea or not? Have you
I
thought
think
about
it is. I think actually it's better. Then you can like rebuild the views simultaneously and then switch with a tricky toggle or something. But sometimes we just wanted to like do like, oh right, we miscalculated here, so we want to like we didn't want to copy the entire logic and everything. So it's just like because we were too lazy like to do it the right way, we added this capability of like resetting a view and rebuilding it. So, but yeah, I think it's best. Also, if you do it this way, you're gonna probably end up with like many tables, like my view version 1, my view version 2, my
But then you can just
you can delete. Yeah, it's another option. Yeah,
you can compare them.
it's definitely valid option. I think we just didn't want like the overhead of managing everything, so we added this capability.
Yeah, and also we saw that with such approach, for example, we can rebuild our views without Kafka. We just lazily, before handling events, we fetch all events, and then everything we have to do
Yeah,
is
so
have
this is a little bit more tricky, because then you need to think about what happens if two calls are coming to two servers
and
together, and
then for example,
this is the problem.
Then you could have kind of also
Lock.
optimistic locking.
So yeah, this requires some coordination of some sort, some lock or some other mechanism, which I thought it was just simpler to handle with Kafka, because this gives you the order guarantee. So
Yeah, but we rejected Kafka because of this cluster thing.
So if you don't use Kafka, you need to think really carefully about like race conditions. What will happen if two reads or two writes come together and they try to rebuild one alongside another?
Yeah, idea was, for example, in our view normalizer, every table contains a version.
Yeah, you can.
And when you update view,
Yeah, you can do like
check this version.
idempotent updates, like
like idempotent updates.
yeah, it's an option. But then again, it's still
Complicates
very
authorization.
valid point. But then you need to be like very aware when you're writing the view denormalizer of this problem. And if you forget in some area to do it, then you can get into trouble. But yeah, that's a perfectly valid approach, I think. I think idempotency is like very important.
Yeah, and also Kafka doesn't guarantee it.
Yeah, so yeah, actually you're right. Yeah, you do still need to think about idempotency in our view denormalizers. I mean, we usually like
But you have separate table where you track what.
I think we have like a version on the rows when you try to update them, so our updates are also like idempotent. So update this if the version matches what we expect. So yeah, I didn't touch too much about idempotency in this talk, but yeah, it's very, very important. You're
And
right.
also you have very great idea, but our system guys will kill us. That actually you can use event stores inside Kafka, for example. If we,
To use Kafka as event store.
yeah, for example, and when you don't need this trigger to rebuild, you always read all events from the beginning. But
Yeah,
then
you
it
know
can
that
block.
Kafka. I think this is one of the like design goals of Kafka. It can be used like an event. This is what the Greyhound team are always like trying to push. Um, but they do have like problems. I think when I try to evaluate it, I think they have problems if you want like to do conditional writes to Kafka. I think you can do it. So when we save persist events in the event store, it will reject the save if the version doesn't match, and I don't think you can do something like this with
No,
Kafka.
I mean, we store everything in the table, and at the same time, event bus publishes everything to the Kafka.
You
and,
mean?
And Kafka itself has
Oh,
no
I see. So alongside,
eviction policy, it's just
yeah.
persistent queue.
But then they're gonna have to like prepare you with your own Kafka cluster because the default cluster doesn't have this retention policy.
Yeah, but makes everything very easy. You
Yeah,
just
because
subscribe to the view and read
that's
from the
right.
beginning.
I think worth a shot. It's also an idea we had. Just
What was the idea?
using Kafka with a retention policy of keeping all messages, and then you can add consumers that read from the like I don't remember what they're called, that always read from the beginning until the very current point. But currently our Kafka cluster is like a retention policy of like 6 hours or something because all the messages are deleted.
You mean like saving forever?
Yeah. This some companies use this approach with Kafka.
And you don't have this separate table where you have what read.
Yeah,
what
this
you
is
don't
like
have
very
triggers.
complex machinery in order to give you these.
And Kafka is like
capabilities,
Kafka
so-
is a database, something like that.
Yeah.
How do you? Yeah, that's like a relevant question from my side. But do you actually? We do not rely on Kafka being fully reliable, right? Or we do?
I think we do. I mean, if you ask like people around the Wix,
Because ICPU's writing down in Slack channel that like Kafka is not considered to be like a reliable source. There will be retries, but it's not like
it
fully
depends
reliable.
on.
It's like a relevant question whether I should, can I rely on Kafka eventually like?
Yeah. So they. It somewhat depends on Greyhound rather than Kafka because the Kafka API allows you to ACK a message, to acknowledge a message. So if you like deal with a message and you're not ACKing it, so Kafka doesn't consider you handled it, and might send it to you again. This is why it's like guarantees at least one delivery. I think Greyhound implemented a library where they like call you and immediately act in order to gain like performance. I talked with Norm about it like a year ago or something, and I asked him if they're planning like to give the option to act the messages ourselves, and he said that they do plan it. But yeah, currently in this like deployment, conceptually, that we do not denormalizer might fail, and Kafka will consider this message like acknowledged. So
Really?
um,
You mean like we ACK always?
No.
On the client side.
no, if like the process falls or something. So if I throw an exception, I don't think they consider it act. But if something falls and I didn't act, so I think it will like be considered like the message was acknowledged. And so yeah, there are still some like edge cases here, but perhaps like the Greyhound now allows us to deal with them.
I didn't fully get it because if Greyhound
Actually, yeah, this is because they wrap everything for you, so it depends on what they do. When do they act the message and what do they do with exceptions? So, yeah, it's definitely worth like investigate all the edge cases like thoroughly.
Yeah. Because we have a couple of use cases right now when we internally process something. Let's say I have to tell one service that something happened, and then I have to tell another service about some fact, some other fact. And these two operations are basically RPC calls. And in case something fails, I would probably like to retry. Um, so, and I'm thinking like about the best way to do it right now. Maybe like just from the very beginning, when there is a certain task to do, treat it as a Kafka.
But I think
event.
also if you just need like to perform some action and order is not an issue for you, maybe it is. But Graham provides like a retrying consumer, which if the handler fails, it will re-enqueue the message and it will try again later. But this messes up orders if you need orders.
I understand. Let's continue then.
Yeah.
So we have a choice right now. Just
How much time do we have?
we have an hour.
I think we might be able to do them both.
Okay.
Because I think it will be quick.
Okay.
All right, let's continue. Okay, so now I'm gonna tell you a little bit about Datomic. This is a database. This entails some similar concepts we deal with in event sourcing, but in quite a different approach, which I think might be interesting. Okay, so Datomic is marketed as the functional database. I'm going to start off with the full disclosure here about I have not used Datomic anywhere like in production. It's just something that interested me, so I played around with it. But I'm not considering myself like an expert in Datomic, and I might not be able to answer everything. Also, why do we need another talk about databases? We have enough problems with the ones we already use. So I think that, like I said, Datomic has some really interesting concepts, and we can benefit from it even if we don't end up actually using it. So just a little background about it. So it was developed by Cognitect, designed by Rich Hickey. You might know him. He's the guy that invented the Clojure programming language. It's been around for a while, since 2012. So it's not just like a new hotness that we must try immediately. It is quite new, but it has some production real use cases. They claim that it's used in Facebook and Netflix and a few others. I'm not sure what exactly for, but this is published on the website, so I don't think they're lying. So let's talk about facts. We can say Abraham Lincoln is the President of the United States. But this doesn't actually represent a fact correctly. A more accurate way would be to say that Lincoln was elected president on March 4, 1861. So we can identify 4 key pieces when talking about facts. We have the entity, in this case, Abraham Lincoln. We have the attribute on which we talk. This is the position. We have the value for this attribute, the president. And we can associate some timestamp in which this fact became known to the world. So Datomic uses this structure to define facts. In Datomic, they are called datums. And they are represented by a 5-tuple. Like we said, entity, attribute, value, transaction, and one more column, which is the operation. You'll see what it's used in a second. So at some point in time, we see that the entity with ID 1033 became known to the world. This entity became was inserted into the system at transaction 260. So we can assume this is like the time that Lincoln was born, and we see that we added these facts about him. Sometime later, we see that he practiced law and he became a lawyer, so this is the position. At some point in the future, transaction 522, we see that the position changed from lawyer to president. So we can assume that this wall clock time that is that matches this transaction is March 4th, 1861, like we saw earlier. And unfortunately, 4 years later, Lincoln was assassinated by John Wilkes Booth. So we need to retract the fact that that he is president, because this is no longer true. Okay, so this is the model that Datomic uses to save our facts. We see that we don't go to some row in some table and change the value in place. We just accrete more and more facts as time passes. And this is actually a model we're very used to work with. So we work with Git every day. Git also keeps all these objects and accumulates them over time. And we have some very nice capabilities we get from this model. How easily we can see how stuff looked like in the past. So this is a capability that we're actually preventing from our users when we go to some table and change some value in a column. And actually, this is not different between like MySQL or MongoDB. It doesn't matter if you're using relational or document. It's the same idea. You're losing valuable information like this. So Datomic gives you this universal schema. Everything is defined in the form of these 5 tuples, these datums. Even its own metadata is saved like entities in this manner. So your attributes themselves, they are entities, and they have some attributes of their own connected to them. Also the transactions, they are just entity IDs, and you can see all the information about a certain transaction just by its ID. So when you define your schema in Datomic, it's quite different than a normal database. You don't need to define your tables and your data types. All you define is your attributes, which type they have, and what cardinality, which means if you have one value or many values. For example, in the previous example, we see like the attribute position has type string and is cardinality 1, because we always have like one value for this attribute. Also, Datomic maintains several indices from like all directions, like index from the attribute, index from the entity, index from the value, which lets you query your data in really interesting ways. And it's not coupled to some data model you need to predefine, because you can look at your data in many ways. You can view it like a key value store if you like read something from the attribute index, or you can use it like a primary key lookup if you look for something by the entity ID, or like a graph database if you follow connections, because the values themselves can lead to other entities, and thus you get this, like you can connect in any direction you want. Or like a column store if you go for the values. So in Datomic, a database is just a collection of datums at a specific point in time. It is lazily realized. I mean, you treat it as a value, but it will fetch its datums as it needs to. And once you get your database value, it's an immutable value. So it's not like working like with a live connection that changes under your feet, to which you like query your issue your queries. You have this, you get the database value from the connection, and then you can treat it the same as you treat like 42 is a value. You can safely share it, pass it between functions, and you can create functions that take in databases and return databases, which is like a really crazy idea. So because of this model, you also obviously get the time built in. You can ask for the current status of the database, but you can easily get the database as it was a week ago. Or you can do like investigate how the database would have looked like as if like certain transactions took place without actually applying these transactions. So you can speculate very easily. And once you have this value of the database, whether it's the speculated value or the real value, you can issue your queries against it, and it will match like the current time of the database value you have in your hands. So this is a really powerful feature. You can also receive a transaction report which lets you build like truly reactive systems. And we'll look closer on this later. So how do you query this database? So this is not using SQL. It uses a form which is called Datalog. It is equivalent to the relation model, but you can also do recursive queries. It's very declarative, expressive, and powerful. This looks like a pattern matching style, and if any of you like did some logic programming or a Prolog or stuff like that, this is like similar concepts. And the queries themselves are described in terms of data structures, not in terms of strings. So you can build your queries like programmatically, and you don't need to do all this crazy string concatenation stuff we sometimes need to do when we're dealing with regular SQL databases. So let's take an example database just to get a feel of what querying in Datomic feels like. So let's say we have these datums. We see several entities, 2 emails, and one entity has 2 orders there. So this is what a data pattern looks like. Its job is to constrain the results and to bind variables. So this is a tuple consisting of 3 parts, and the order of the parts is similar to the form of the datum. So we have the entity first, the attribute later, and the value afterwards. We can also extend it to use more parts, like if we need to do something with a transaction, or use less parts if we don't care about the value, for example. So we can see also that some of the parts here are prefixed with a question mark. So these are variables, and the parts that are not variables are considered constants. So how this works is, for example, if you want to find all customers with emails. So I fix the constant part to the email attribute, and then the customer and the email variables are bound to the results in the database. So by using this query, we'll get 42 and 43 and the 2 emails. Or for example, if I want to find a particular customer's email, I can use more constants. If I want to use the entity ID here and the email part, so the email value will just be bound to the correct value I'm looking for. Or for example, like I said, we don't have to use all the parts. I can check what attributes 42 has. So I see email and orders. So this is a very flexible manner of querying your data. what attributes and values also. This is really flexible. You can use constant or variables in which place you want. So a query looks like this. It contains a where clause, which contains the data patterns we described, and a find clause, which tells us what we want to get out of the query. So this is like the select whatever, and the where is like the where. So also you get with the Datomic and implicit joins, variables that are bound to the same name have to be unified when the query is run. So if I put on two data patterns there, I can find all customers who have placed orders, because I need a customer which has both an email attribute and an order attribute. Also, you can use predicates. For example, find expensive items. These are simply function calls. This syntax looks a bit strange maybe because this is like infix notation, but this is what Clojure programmers are used to, and this is like the data structures are ported from Clojure. So this is like the idiomatic way to do it in Clojure. But the cool thing is, like I said, these are functions used in predicates. You can also call like user-defined functions. These are functions you defined within your process, like a static method in Java, and you can create queries that run your actual functions, and you can make decisions upon them when running a database query. So this is like a really powerful feature. Now this query looks quite daunting, and it's big and might be confusing, but this will find all the customer product combinations where the shipping cost dominates the product cost. So if you have like a business rule where you don't want to ship a product if the shipping cost is greater than the product cost, you can notify the customer that they cannot ship this product, and you see this. There's a call here for shipping estimate, which is just a user-defined function. And if you try to do like the equivalent thing in SQL, I assume this is going to be very difficult for you. So a bit about Datomic's architecture. So most databases have many roles they need to take care of. They need to execute queries. They need to apply transactions and coordinate between the two, and they need to ensure consistency between all these parts and write to durable storage. So these are a lot of parts, and this is why most databases are such a complex piece of machinery and very hard to get right, and this is why we have so many problems, like we mentioned before, like replication and dirty writes, dirty reads, all sorts of like isolation level fun. So Datomic takes a little different approach by breaking everything down to several components. So the components Datomic uses is first the peer library, the transactor, and the storage layer. This is one example of how the Datomic setup might look like, but it's not fixed. You really have flexibility to change how the parts are working together. So I'll describe what each part is responsible for. So the peer library is just some jar embedded in your application, and it will execute your queries. This is starting from here. We see that this is very different from most databases, because what you usually do is you send your SQL string to the database, and he has the brain to run your query and give you the results. So Datomic takes a different approach. It will run the query actually in your process, not in some database brain somewhere. So it will read the data, which is just the datums it needs to execute the query, and it will cache them locally. And because the queries are run in your application, you can very easily scale horizontally, because you're not dependent on someone to do the work for you, because you just add more application servers and you can handle more queries. Another benefit is you have no problem like running some really big analytics query, for example, that takes a really long time. You're not going to block anywhere, no coordination is needed. And you can read it directly from your production database, and you don't need like all sorts of replicas and data warehouses. You can just run your queries, and you won't interfere with anyone. The next part is the transactor. This is part that's responsible for applying your transactions. This is a standalone service which scales vertically. So this is where you need to invest like in a big machine. You can use it in like high availability mode with hot standby for failovers. And its job is to coordinate the writes. And it does ACID transactions with isolation level serializable, which is like the highest level of isolation levels if you know a little bit about the database theory. You achieve this by the simplest way possible, but just by using a single thread on a single process to apply your transactions. So this doesn't sound like something you'd want to do, but if you look into most databases, you'd see that they spend most of their time doing coordination and only about 25% of their time actually executing your transactions. And because the transactor is not involved in any coordination whatsoever, all it needs to do is accept new transaction and apply them, you can get into really big scale before you hit any performance problems. So this is already very different from what we used to work with. So the next layer we have is the storage layer. Also, the transaction will write the transaction log into storage. It will create the indices for everything we talked about previously. And it will broadcast live updates. So if you want to create like reactive system, you can quite easily like tap into the transaction log and respond to the transaction. So like we talked about with the event sourcing and everything with the event handlers, this is like a similar concept. Now the storage layer is provided as a service, and Datomic doesn't actually does storage for you, and you can swap in many different backends as you see fit. So you could use like local storage setup, which uses, for example, the memory of your local file system, and this is really awesome for testing. You can boot up your entire system and just use your database in memory, and the test will run super fast. You can also use any JDBC for SQL database. You can use some cloud storage like DynamoDB or Cassandra or Couchbase, depending on your like production needs and availability you need. So this is a storage layer, and a usual setup will also include, for example, some caching layer between the storage and your peers. Just to make things faster, you can introduce some Memcache layer. And because everything is immutable, all the datums are immutable, the caching policy is extremely simple because you don't need to expire everything, you don't need to invalidate anything, so caching becomes super easy. One other benefit from this setup is your transaction might fail, but you will still be able to execute queries, because if your storage layer and your apps are available, there's no problem like continue serving queries. You just won't be able to transact new data into the database. So like I said, this brings similar concepts we get from event sourcing, but I think the differences are firstly that Datomic is lower level, because you're dealing with facts which like are more fine-grained than dealing with events, which usually tie to your business model. However, if you did wanted to get some of the benefits of event sourcing, like being able to tell what's the business event that happened that got you to this state, you can easily annotate your transactions. So you can say that these 4 datums in these transactions are related to this event or this command, because, like I said, the transactions themselves are just entities, and you have no problem like adding new attributes on top of them. So you can say that transaction 160 has the attribute of, for example, command ID that caused this transaction, or event name that that is more business related. Also, you have querying built in. If you're dealing with event sourcing, we saw that it's not the easiest thing to do when we want to like try to query our data, but Datomic gives us a really powerful query model, which lets us do very complex and interesting queries out of the box, and we don't need to create all this machinery around it. So this is really powerful. When you start working this data log thing, it's really addictive. I mean, you can do stuff that took you in SQL, very difficult queries, you can do quite easily. Also, like I mentioned, if you listen on the transaction queue, you can get the transaction reports as they come and react to them. And this is another powerful feature you get from Datomic. So this is basically it. Again, if you have something to ask, I'll do my best to answer it. Yeah, so like I said, no production system I deployed with Datomic, but I did play around quite a bit with it, and it was really nice to work with. I know there's some really big bank in Brazil which use it like for their main data store. So Datomic, so Brazil is a big country, and bank usually like has a lot of operations going on. So they always give like talks about how Datomic helped them. So you can find this sort of material on YouTube. So there are people using it in production and seeing its benefits. Yes, so the indices are, okay, I'll repeat the question. How does it support all the indexes, and where the indexing actually takes part? So the transactor is responsible for generating the indexes, but it will push back to all the peers connected to it, the indexes, so they can run the queries quickly and performantly. Yep. Okay, so the question was how the read path goes. Yes, so wait a second. Let's go back here. So, no cursor. Okay, so this is your app. For example, Wix invoices. When some query comes to my app and I want to read some data, I have this connection object I mentioned, and to which I'm telling, okay, give me the current value of the database. Like I said, I can ask for it for the value of the database a week ago, but usually what's interesting is like the current state. So I'm getting the current value of the database, and then I can write a function that will query this database. This database value is not like, I said you can treat it like an immutable value, but it will read from storage as it needs. If it doesn't have all the information it needs to execute my query, it will fetch it from storage. it might be that after some time, if a lot of like similar queries will come to this app, the cache will already be warm and every datum that it needs are already in the cache, and you might answer queries immediately without the need to go over the wire at all. So this also might happen, but this is like the read path because the datums are stored in storage, and your pure library will get what it needs from storage, cache it, and execute your query on your app server. I hope that explains it. So if you need a full table scan, there are no magics here. I mean, if you need full table scan when you're using MySQL, someone is going to have to do this full table scan. It's you just don't feel it because you delegate it to the box of the MySQL. But if you need a full table scan here, you'll do the full table scan in your application. This is why you probably want like to over provision like your app servers and scale this part horizontally as much as you can, or avoid queries which require full table scan, like optimize your queries, again, similarly to what you do in other databases. I mean, there are no magics here. It just like breaks down the different responsibilities and tries to separate the things so they can work better and you can make other architectural decisions based on them. All right, so if no more questions, yeah. Mm-hmm. Okay, so the question was how to deal with Okay, so the question was, for example, in MySQL, you can avoid full table scans by providing database views over your data, which will allow simpler queries. So this, I don't think, don't get me by the word, but maybe it's not supported like out of the box, but since you get this live transaction report, you can create your views on your own based on these transaction reports if you need like some immediate data and you don't want to perform these scans. So this is what MySQL gives you like out of the box to create these views. Maybe you can do the same according to the live transaction report and create some similar idea on your app. But I'm not entirely sure that it comes out of the box. So. For what? For the queries? Actually, the queries themselves that look. Okay, so this is. Yeah, I understand. So I'm just gonna go and look in a second. But basically, most of the thing is this big data structure, which describes the query, and around that you'll usually see like a function call to the query function, and you pass it this query object and the database value. Let me see if I can find some example. So this is without the. All right, so it looks something like this. Where was it? This is they like short names. It's sometimes very confusing, but this is datomic/query, and this is the actual query. You find Also, you see here an example for aggregation, which I didn't talk about, but you can do like sum and count and stuff like that. Also, and you pass it the value of the database. Now, this is where the part that I mentioned that you can pass in the database like in a different point in time. So you just need to pass in the value of the database in past time, for example, and you see the results for this query in past time. So this is what it looks like just a little wrapper. Also, you don't see it here, but if you want some like binding with outside variables, like you do with prepared statements, for example, you have a way to achieve this by passing additional arguments to the query function, and then you have new bounded variables inside your query. So this is what it basically looks like. Let's see if I can find another. No other examples here. Maybe here. Nope, but I am sure you can find it in the. Okay, there are also a few more resources in the slides. I'll share them later with you. Great. So I think we have time also for the final one. You want some break or you want to continue? Right. Let's keep going. Okay, this is the last one. Coming back to our functional stuff, I'm going to talk about transducers. They're also related to the closure world, but decoupled from it. Now I searched for Google Images for transducers, and this is all I could find, like these industrial parts. So I have no idea what they're doing. So maybe one of you knows. Also, I'm going to start by saying that I tried to make this presentation in Scala, but the type signatures became so confusing. So I decided to take a simpler approach and do it with JavaScript. I hope we'll get through them together. It's not that difficult of a syntax, and I'll explain the different parts. It just, I think, concentrating on the type signatures will just confuse and direct the focus from what's really important. So, okay, so we use all the time in our day-to-day job collection transformations. For example, we have this collection that contains the numbers 1 to 6. We have some functions, for example, for doubling a value, for checking if a number is even. So we can easily map this collection with a double function, and we get the numbers doubled. Or we can filter this collection and get just the even numbers. This is something we're used to doing every day. Also, we can reduce this collection to get the sum of all numbers. This is the equivalent in JavaScript to a fold left in Scala. So you start with some seed value 0, and then you have a reducing function that takes the current accumulator and the next item, and it will do whatever you need to return the next accumulator. So this, for sum, you just add the two together and you get 21. Now, by looking at these, can anyone see what all these have in common, all these operations? Anyone has an idea? Okay, this is a start. But another thing is that all these operations, map, filter, and reduce, we can define all of them in terms of reduce. So sum is already defined as a reduce. Let's see how map and filter also can be defined like this. So map takes a collection and some transformation function. Filter takes the collection and some predicate. They all call reduce on the collection, passing in a seed value of an empty array. And then they have the reducing functions. I'll explain the syntax. For the map, you see the accumulator and the item, and this syntax just creates a new array with all previous value in the accumulator. This is like the spread, the three dots there, plus the new item with the transformed by the function. And the filter similarly checks if the predicate returns true for this item. If so, it will add it to the new collection. Otherwise, it will return the current accumulated value. So this way, we get the same result. Some observations we can see from this pattern is that the actual logic of the transformation is contained within the reducing function. Everything else is just like boilerplate. One other thing is that we are coupled to our input and output types. We take in an array, we are coupled to the fact that it has a reduce operation on it, and we build up a new array. Again, we're coupled to dealing specifically with arrays here. Also, if we want to chain several of these operations, we will introduce intermediate results. So if we do collection filter is even, then map to double, this will actually create a new collection for the is even part, and then it will create a new collection for the mapping part. So this is quite wasteful. So let's see how we can deal with these problems. First thing, logic in the reducing function. So we just extract the logic. So if we want to extract the logic for the map, it's just the reducing function for a map. So we take in a function, a transformation function, and then we return the reducing function for map, like we saw earlier. Similarly to filter, we take in a predicate, and we create the reducing function for the filter. Now we can create this run function that will just apply the reducer on an empty collection, and then this works as expected. We map it to double, we get the expected result. Now the second problem we mentioned is coupling to input and output types. So to deal with this, we will inject some other function to the reducer, which is a step function. So if we have these implementations, to both we're going to inject another function, which is the actual step we're going to do, which might be to create a new array or might do something else. And instead of creating a new array, we just call the step function here. Now, if you pay close attention, you'll see that this step function has a signature similar to the reducing function. It takes in the accumulator and the current value and returns some new value. So by doing this simple operation, we actually created the transducer. So if the reducer signature it takes the whatever and the new input and returns whatever, a transducer, sorry, this is difficult to pronounce. The transducer will take a reducer and returns another reducer. Okay, so this is okay. So like you see, you take the reducer, which is the step function, and return another reducer. So this created the transducers. Now, after we've done that, we can create this function, which is called transduce. This will take the transformation we want to do, the step function, the initial seed value, and the input. By applying the step function to the transformation, we get the reducer. And then we can iterate over our input and use the reducing function to accumulate the current value and return it at the end. So let's see some examples. We can create these step functions that we've seen before, that into will create a new array and will pour the new values into this array, and the sum function that just accumulates the values and returns the sum. So if we create our transducer now with a new signature, for example, our transformation is to filter the even numbers, and we take the collection. we can use the same transformation, the same filter, to do both. Also to create the new array with 2, 4, 6, and also to sum if we start with a seed value of 0. So this is a nice way to achieve the decoupling from our input and output types. So the process itself, the filtering in this example, is completely separate from the input and output sources, which means we can reuse this transformation, for example, like we saw with the built-in collections with arrays or numbers, or we can use some custom collections, like for example in JavaScript you have a library which is called immutable.js, which creates like immutable values, and you can just create a step functions that will build up these collections and use the same transformations. These are simple functions. Or you can use streams or like stuff that are not necessarily terminating or infinite, like WebSockets that use the same transformation logic and apply it to the stream. The third problem we mentioned is the intermediate results. The solution here is already provided us out of the box, which is just function composition. Unfortunately, JavaScript doesn't have built-in compose function, so I'm just going to implement it here. This just composes a list of functions, again, by using reduce, with an seed value of the identity function. So after we have function composition, we can easily compose these two transducers to get a new transducer. And now we are both filtering the even numbers and mapping it to double. And because all of this is just function composition and just a chain of function calls, no intermediate results are created when applying this transformation together. So I'm using the compose transducer, and I'm doing the similar thing. It first filters the even and then doubles, and I get the expected results. So a little bit about stateful transducers. An example is drop. We want to remove the first n elements of a collection. So to do this, we create an immutable value, the remaining counter, which we initialize to n. In the reducing function, all the time we will decrement its value. If we haven't reached our 0 yet, we just return the accumulated value. And once we're at 0, we're going to want to actually apply the step function. This will drop the first items. So this works as expected. We want to drop the first 4 elements. We get just 5, 6. One other thing we might want to include in our transducers is the ability to terminate early if we understand that our transformation is complete and we don't want to do any more work. So to do this, we're going to have to denote somehow that this value is the last value and we don't want to continue. So I'm creating a new function here called done, which takes the value and just wraps it with some object that describes this is the last value. And just a small modification to the transduce function is after the reducer call, I'm going to check if this is the last value. If so, I'm going to extract the actual value from it and break out of the loop, so I don't have to do any more work. So example of this would be to implement the take function, which takes the first n elements. Now, if I have a collection with 100 elements and I do very tricky transformation there, I don't necessarily want to do it for everything in the array. I just want to take the first 5 elements. So this is very similar to what we had in the drop case. But here you can see if I still have remaining items to take, I apply the step function. Otherwise, I'm telling I'm done. This is what the accumulated value is. And then I get this behavior. I'm taking just 2 elements from the collection and just get 1, 2. And I'm not continuing to go over the rest of the collection. This gives us like a bonus feature that now we can use infinite collections. Now, JavaScript doesn't have like the stream like we're used to in Scala, but they do have in ES6 they have like generators. If some of you know like Python, or they have them in PHP now, I think. This looks like a function with a while true loop, but it won't actually like run through the loop. It will every time will yield a new value, and it will wait for you like to take this value until it will continue to the next iteration. So this function will actually generate like a lazy stream of all numbers. So now we can compose these transducers. We filter even, map to double, and take just the first five elements. And now if we use the numbers function instead of just the normal array we used earlier, it will stop and give us the result of these numbers as expected. So this is it. I thought it might be nice to demonstrate it. There's also a library for transducers in Scala. Like I said, I wanted to keep the examples simple and not to get into like tricky type signatures there. I recommend you watch the talk by Rich Hickey again. It all boils down to Rich Hickey, I think. And that's it, unless, again, I'll send the slides later, don't worry. Everything clear? Awesome. Okay, thanks very much for listening. This is all I have for today. Maybe next time I'll have some more stuff.
Thanks, everyone. So tomorrow we'll have another session at 10 about production incident management from Anna and from Alex. So please come over. We'll also do the recording tomorrow of this stuff. Thanks, Amitai, for joining us today and making a full-fledged Server Guild day today.